Okay, dear students, welcome to the live. In last session, we have seen which are the important topics you need to focus for GATE as well as for ESC. Today, I will take up one interesting concept. Here you will understand if you simply mug up the formula, how you are going to do the mistakes, you will understand. Okay, let me give you. Here is one beautiful question. Given that a stress axis and a strain axis, this is a stress strain curve for concrete. Here mentioned that assume straight line instead of parabola for a stress strain curve of concrete. Actually, the design stress strain curve for concrete is parabola up to 0.002 strain and constant till failure. Actually, IS code adopted that the failure strain in concrete is 0.0035, but here modified, it is given that 0.003, right? Actually, it is a parabola, but here given straight line, right? Stress strain curve of concrete and partial safety factor for concrete and steel are 1.3 and 1.1, given that partial safety factor 1.3 and 1.1 respectively. A rectangular reinforced beam concrete section of 300 mm width of the beam given 300 mm and 500 mm effective depth given 500 mm is reinforced with 3 bars of grade Fe415 each of 16 mm diameter, given 3 bars of 16 mm diameter with a grade Fe415. Concrete mix given that M20. What is the question? The depth of neutral axis from the compression fiber is, my dear, suppose if you mug up the formula or if you by heart the formula and write down directly, you will get the wrong answer, right? If you don't understand the concept clearly, 100% you will do the mistake. So first I will explain the concept, thereafter I will take up this question, okay? Let us see the concept for this. To find out actual depth of neutral axis, you must equate compressive force to tensile force in limit state method. So, you have to know how compressive force is coming and how tensile force is coming, right? For that, you need to understand first what is a stress block and what are the stress block parameters, okay? Let me give you first stress block. What is mean by stress block? Stress block is nothing but stress diagram of concrete in compression zone. In limit state method, stress block consists of partly rectangle and partly parabola. The design strength of concrete is 0.446 FCK and this is the neutral axis position. If you observe, in a stress block, partly it is a rectangle, partly it is parabola. This is a stress block, right? Then what are the stress block parameters? Let me give you stress block parameters also. Stress block is nothing but stress diagram of concrete in compression zone, right? In limit state method, we are going to take, it is a rectangle and parabola. Let us see stress block parameters. Stress block parameters. Stress block parameters. My dear, I'll give you first a visa stress block. This is a stress block, right? Partly rectangle, then partly parabola, right? Design strength of concrete is 0.446 FCK. My dear, This is stress block. Under stress block parameters, first one is ordinates of stress block. We have to find out first the depth of parabola and depth of rectangle in a stress block. Right. Here directly we cannot find, we can find from the strain diagram. So I will give first corresponding strain diagram above neutral axis, because you cannot find directly the depth of parabola and depth of a rectangle in a stress block. Let us observe the strain diagram. It is 0.0035. Standard one I am taking. This is the neutral axis position. This is the neutral axis position. Okay. You know the strain in concrete at this level is 0.002. We can say that up to 0.002 strain, the stress diagram is varying parabolically. Beyond that, it is constant till failure. Okay. It means if you find the height in a stress diagram up to 0.002 strain, you will get the depth of the parabola in a stress block. Here, if you measure the distance from extreme compression fiber to till neutral axis, my dear, this is XU. This is XU. Okay, na? Right. Then how do you find out the depth of parabola and depth of rectangle in a stress block? My dear, you take simply similar triangles. From the strain diagram, we'll give the H. Once if you get the H, that is the depth of parabola, then you can find out easily the depth of rectangular portion. How do you find it? From strain diagram, just by taking similar triangles. This is one triangle up to 0.002, then it is another triangle up to 0.0035. H upon XU equal to 0.002 upon 0.0035. For a depth H, strain is 0.002. For a depth XU, strain is 0.0035. If you simplify, then you will get 4/7. From this, you will get H is equals to 4/7 XU. This is 4/7 XU, right? This is 4/7 XU. And remaining depth of rectangle, total depth is XU, then what will be the depth of rectangular portion? Total depth minus depth of parabola, you will get, my dear, 3/7 XU. Right, first step completed. Ordinates of stress block. We can get ordinates of stress block by taking similar triangles from the strain diagram. Then how to get the compressive force? My dear, we have a stress diagram. We can find out compressive force. It's not a problem. If you know how to get the force, once you know the stress, then you will get here compressive force. This is the stress block. You know, it is the 0.446 FCK design strength of concrete, and this one be the depth of rectangle, say 3/7 XU, and it is a depth of parabola, say 4/7 XU, 4/7 XU, right? Now, I would like to take the beam cross section up to, right, up to the neutral axis position. So what is the width of the beam? Width of the beam is, say, B. Width of the beam is B. Now take, my dear, this one. It is a rectangular portion. Up to this height, you will find the rectangular portion. And you will find remaining depth is parabola. Okay. How do you get the compressive force? Compressive force you can get like this. Compressive force equal to average stress into corresponding area. Average stress into corresponding area. Average stress into corresponding area. My dear, what will be the average stress for a rectangular portion? Same only. Average stress is 0.446 FCK. This is the average stress. Into corresponding area, this rectangular portion area, it is B into 3 by 7 XU. Now, average stress you are getting 0.446 FCK and corresponding area from the beam is B into 3 by 7 XU. Plus, what about the parabolic portion? Take the average stress into corresponding area. Average stress is 2 by 3 into 0.446 FCK. This is the average stress. What is the corresponding area from the beam? Area from the beam is B into 4 by 7 XU. Right. Let us simplify this. My dear, if you simplify, you may get 0.36 FCK into B into XU. This is the compressive force. First one under stress block parameters is ordinates of stress block, where ordinates of stress block is nothing but what is the depth of parabola and what is the depth of rectangle in a stress block. This you can get from the strain diagram by taking similar triangles. Second one is compressive force. How do you get concept? Average stress into corresponding area. Okay. Then where this compressive force is acting? It is acting at centroid of stress block. It is acting at centroid of stress block. It is acting at centroid of stress block. So you need to find the centroid. My dear, this is the stress block. And this is the design strength of concrete 0.446 FCK. You know this height is 3 by 7 XU. And this height is 4 by 7 XU. Okay. What is the centroid of the stress block? Suppose if it is complete rectangle, we can say half of the depth. If it is complete parabola, then also we can say 3 by 8 times h. But it is not completely rectangle, not completely parabola. Then how do we get centroid of the stress block? You know from strength of materials, y bar equal to A1 y1 plus A2 y2 upon A1 plus A2, because I want centroid in the depth direction. So we can find out y bar. What is here A1, what is A2, what is y1 and what is y2? Let us see, my dear. A1 is nothing but area of the rectangular portion. It is 0.446 FCK into height is 3 by 7 XU. Then what is A2? A2 is 2/3 of 0.446 FCK into 4 by 7 XU. Then what is a y1? Y1 is, my dear, a rectangular portion. So centroid will be half of the depth. Half of the depth. Then what is the centroid of parabola? From top I want y2 equals to 3 by 7 XU plus 3 by 8 times h, where h is 4 by 7 XU. My dear, if you substitute and simplify, you may get y bar equal to 0.416 XU, we take nearly its value is 0.42 XU. Its value is 0.42 XU. These three are the stress block parameters. Okay. Then how to get the tensile force? Let us see. Tensile force I want. Tensile force I want. You know the stress diagram? The stress diagram comes for a singly reinforced beam in limit state method like this. This is the stress diagram, right? The design strength of concrete is say 0.446 FCK and the design strength of steel is say 0.87 Fy. We want, my dear, we want tensile force, right? Tensile force equal to T equals to design stress into corresponding area. No need to take the average stress because stress is not varying in tension zone. Stress is acting only at the level of steel. So you take directly stress into corresponding area, or you can say design strength of steel into corresponding area. This is the tensile force. It is acting at centroid of tension steel. It is acting at centroid of tension steel. Okay, like this you can get the compressive force and tensile force. Okay, then how to get the actual depth of neutral axis? How to get actual depth of neutral axis? The concept to find out actual depth of neutral axis is just by equating compressive force to tensile force. What is the compressive force? 0.36 FCK B into XU, which is equal to tensile force is 0.87 Fy AST. From this you can get actual depth of neutral axis, say 0.87 Fy AST upon 0.36 FCK into B. From this you will get actual depth of neutral axis. Okay, what is the question? Actual depth of neutral axis in the beam is, right? Okay, let us go to the question now. Let us check once again before going to solve the question. If you don't have a clarity in the question, my dear, it is not able to get the correct answer. You may get the answer, that answer is waiting for you in one of the option, right? That is the beauty of GATE as well as ESC. However you do, you will get one value. That value will be there in options, right? If you do wrong answer, option is there. If you do right answer, option will be waiting for you. Okay, na? Right. So don't do silly mistakes. To avoid silly mistakes and also to get the accurate answer, you must have clarity in concept. Now see once the basic concept, then I will solve that question. What is stress block? Stress block is nothing but stress diagram of concrete in compression zone. In limit state method, stress block consists of two different shapes. One is rectangle, another one is parabola. Okay. Then what are the stress block parameters? There are three stress block parameters mainly. One is ordinates of stress block, nothing but depth of parabola and depth of rectangle in a stress block. How much is the depth of parabola and how much is the depth of rectangle? How do you get? From strain diagram, take similar triangles, you will get depth of parabola. Once if you get depth of parabola, you know already total depth. Easily you will get, my dear, the depth of rectangular portion in a stress block. This is the first one. Ordinates of stress block can be obtained by taking similar triangles from the strain diagram. Okay, concept is clear, right? Then next step, compressive force. Compressive force you can get it from the stress block by taking corresponding width from the beam. How? Stress equals to mathematically force upon area. Now force equals to stress into area. Here stress is not uniform, so you can take average stress into corresponding area, right? If you simplify average stress into area, for the standard case you will get 0.36 FCK BXU, which is compressive force, right? Where it is acting? It is acting at the centroid of stress block. Then how to get the centroid of stress block? Very simple, since the shape is not uniform from top to neutral axis. So you can go to the standard formula, that is centroid of a standard case A1Y1 plus A2Y2 upon A1 plus A2. That means whole figure divided into two different shapes. One is rectangle, another one is parabola. And we are finding A1Y1 for this case, A2Y2 for this case, upon total area will give the Y bar. My dear, you know area A1, A2, Y1, Y2. Just substitute the values, you will get after simplification 0.416 XU. Then we can take generally round figure 0.42 XU. Okay, it is not required actually to determine the actual depth of neutral axis, but to find out further concepts like moment of resistance, you must know how to get the centroid of stress block. Okay, right. Coming to the next one, tensile force. To find the actual depth of neutral axis along with compressive force, you must know how to get tensile force also. Tensile force is design strength of steel into corresponding area of steel. Here design strength of steel, how do you get it? Design strength of steel equals to yield stress upon partial safety factor for steel. Here partial safety factor for steel as per IS code is 1.15. If you simplify this, you will get 0.87 Fi. This is the design strength of steel. Now, tensile force equals to design strength into corresponding area. My dear, you will get the tensile force, right? Yes. Then what is the concept to find out actual depth of neutral axis? Simply equate compressive force to tensile force. You will get actual depth of neutral axis. Okay. Now we will take one question. Yeah, this is a question. Assume straight line instead of parabola. Actually, we have taken parabola in a stress block, but here they have given straight line instead of parabola, right? Then given that partial safety factor for concrete is 1.3. Here partial safety factor given 1.1. Actually, how do we get this 0.446 FCK? Design strength equals to 0.67 FCK upon partial safety factor for concrete. My dear, partial safety factor for concrete, if you take 1.3 and simplify it, you will get 0.446 FCK. Okay, right. Then come back to the question. My dear, partial safety factors given for concrete as well as for steel. A rectangular reinforced concrete section, 300 mm width and 500 mm effective depth. B given that 300 mm, effective depth given that small d, right, is reinforced with the 3 bars of Fe415 grade steel and 16 mm diameter. Concrete mix is given M20. Question is the depth of neutral axis. Suppose if you write here XU equal to 0.87 Fy AST upon 0.36 FCK B, this is wrong. This is wrong. because partial safety factors changed in this question. Even shape of the stress diagram also changed in this question. So this formula is not valid, right? If you don't have a clarity in concepts, you are going to write directly this formula, right? Then 100% answer will get wrong. Then how to solve this question? How to solve this question? Once again, I would like to take the stress block as well as corresponding strain diagram. Okay, fine. Fine. What to do here? My dear, first of all, we want compressive force and tensile force. For that, let me take a beam cross section. A beam cross section like this. Okay. Width of the beam, say B. This is a neutral axis position. Say above neutral axis compression, below neutral axis tension. Above neutral axis compression, below neutral axis tension. Now in tension zone, we are placing the steel reinforcement. Say its area be the AST. Then what about the strain diagram and the stress diagram corresponding to this? My dear, let us take now strain diagram. We know that varying linearly based on the assumption, my dear, plane section remains plane before bending, even after bending, based on that assumption. You know, here the strain will be 0.0035. Somewhere you will get the strain will be 0.002. Here the strain will be 0.002 plus Fy upon 1.15 times Es. But here modifications you have to observe. Actually, it is modified. It is not 0.0035. Given that it is 0.003. Even partial safety factor, it is also modified for steel, it is 1.1. Observe here. Here given that 0.003 and partial safety factor given that 1.1. Okay. Then how is the stress diagram? Let us check the stress diagram for this case. This is the stress block. Actually here parabola na, here modified. In place of parabola, they have given that straight line. Okay. And it is the design strength of steel. How do you get Fy upon 1.1? What is the design strength of concrete? It is 0.67 FCK upon partial safety factor 1.3. Right? It is straight line up to a strain 0.002. In order to get actual depth of neutral axis, we required compressive force as well as the tensile force, right? So, you have to find out first what is the depth of triangular portion and what is the depth of rectangular portion. How do you get this? From strain diagram by taking similar triangles. Let us say this height is a h. Say this height is x. Okay. Now from strain diagram take similar triangles. We want ordinates of stress block. Ordinates of stress block. Ordinates of stress block. See my dear, from strain diagram take similar triangles. From strain diagram take similar triangles. From strain diagram take similar triangles. that is for a depth XU, strain is 0.003. For a depth H, strain is 0.002. I can write down from this H upon XU equal to 0.002 upon 0.003. That is 2 by 3 you will get. If you check once, for a height H, strain is 0.002. For a height XU, strain is 0.0035. If I simplify, I am getting it is 2 by 3 XU. Total is XU. If it is 2 by 3 XU, remaining is 1 by 3 XU. Okay, na? Ordinates of stress block we are getting. Depth of parabola and depth of triangle and depth of rectangle we are getting. This is the depth of triangle. Depth of triangle. Then we want depth of rectangle also in a stress block. Depth of rectangle in a stress block, that is total depth minus 2 by 3 into XU. That is, you will get XU by 3 or 1/3 XU. Okay, first step completed. Next step, compressive force. We want compressive force. Compressive force C equal to average stress into corresponding area. Average stress into corresponding area. My dear, what is the average stress here? If you go back to the figure, first we have to take for rectangular portion, then we will take for triangular portion. That is 0.67 FCK upon 1.3. This is the strength of the concrete we have to take. Into area will be B into, my dear, XU by 3, 1/3 XU. Then what about the area of, that is average stress of triangle? Half into 0.67 FCK upon 1.3. This is average stress. Into area. Area will be B into 2/3 of XU. 2/3 of XU. Okay. Now simplify. You will get, my dear, compressive force. That is, wait a minute, 0.67 upon 1.3 into 3. You will get this part is 1.546. 1.546. You will get this part is half into 0.5 into 0.67 upon 1.3 into 2 by 3. I am getting 0.172. 0.172. Total is 0.172 plus 1.546. 1.546 is not correct. Somewhere it is wrong. Wait. 0.67 into, 0.67 upon 1.3 into 3. Yes. 0.17 this value also. 0.17, 0.17. 0.34 we are going to get. 0.34 we are going to get. It is not 0.36. We are going to get 0.34. 0.34 FCK into B into XU. Okay, we are getting compressive force. Then what about the tensile force? My dear, tensile force we can get like this. We get the tensile force equal to T equal to design strength into corresponding area. Fy upon partial safety factor 1.1 into AST. This is the tensile force. Okay. We don't write simply 0.36 FCK BXU and 0.87 FY AST. As they modified the values, so you can take like this. Okay, right. Now, how to get the depth of neutral axis? How to get depth of neutral axis? Either it is a depth of neutral axis, or we can say, my dear, actual depth of neutral axis. Okay, right. That is, concept is equating compressive force to tensile force. Here compressive force is, my dear, we are getting compressive force is 0.34 FCK BXU. 0.34 FCK B into XU. Tensile force we are getting Fy upon 1.1, Fy upon 1.1 into AST, right? Okay, then substitute the values, you will get the XU value. 0.34 into FCK, concrete grade given in the question is M20. So, FCK value will be 20. What is the width of the beam given? Width of the beam given 300 mm. So, it is FCK 20 given, B given 300 into XU equal to Fy. What is the grade of steel given? Grade of steel given in the question is Fe415. And how much is the area of steel given? 3 bar 16 mm diameter. 3 bar 16 mm diameter. Right. Fy is the 415 upon 1.1 into AST. AST will be 3 bars into 5 by 4 into 16 square. My dear, you will get the actual depth of neutral axis from this. Okay, fine. That is 0.87, sorry, Fy 415 upon 1.1 into 3 numbers, 16 mm diameter, its area will come around 201 upon 0.34 into FCK 20 into B will be the 300. Right. So, you are going to get 111.51 mm. Right. Actual depth of neutral axis, you are going to get 111.51 mm. Let me check once again. It is 415 upon 1.1 into 3 numbers into 201 upon 0.34 into FCK into B. Yes, I am getting 111.51 mm, 517, let us say 52, let us say 52 mm. Okay, na? Suppose if you try normal case 0.36, now check what will be the difference will come. Suppose if you are going to take 0.36 FCK into BXU equal to 0.87 into Fy into AST. Now 0.36 FCK value is 20, B value 30 into 300 into XU equal to 0.87 into Fy into AST is 3 numbers 5 by 4 into 16 square, that is 0.87 into Fy into 3 into 201 upon 0.36 FCK into B is 300. I am getting the value 100.79. 100.79. XU value we are getting 100.79. See the difference, 100.79. For example, if you take, it is nearly 112 mm, and this value you can take it nearly 101 mm. Now the difference is there, na? 11 mm difference is there. Okay. Suppose if you don't modify, the difference will be For this problem, 11 mm, right? Okay, so final conclusion is, if you don't have clarity in concept, my dear, or if you are not strong in concepts, then difficult to solve the questions in GATE as well as in ESC, right? Okay, my dear, I wish you all the best.
I am Nikhil Kumar Saha. I got AIR 1 in GATE Mechanical 2022. I was enrolled in ACE online test series program. So test series, whether it would be subject wise, topic wise or full length test, it helped me to improve my numerical solving skills in all the domain of the subjects that are included in mechanical. It helped me to cope up with the new numerical type of problems which normally students face difficulty in solving in first go. So it helped me to cope up with this type of numericals, and also I got to know through different multiple choice questions, multiple select questions which are now in the GATE Mechanical they have introduced. So I got very good quality questions, so it helped me in preparation a lot. I am Nikhil Kumar Saha. I got AIR 1 in GATE Mechanical 2022. I was enrolled in ACE online test series program. So test series, whether it would be subject wise, topic wise or full length test, it helped me to improve my numerical solving skills in all the domain of the subjects that are included in mechanical. It helped me to cope up with the new numerical type of problems which normally students face difficulty in solving in first go. So it helped me to cope up with this type of numericals, and also I got to know through different multiple choice questions, multiple select questions which are now in the GATE Mechanical they have introduced. So I got very good quality questions, so it helped me in preparation a lot. I am Nikhil Kumar Saha. I got AIR 1 in GATE Mechanical 2022. I was enrolled in ACE online test series program. So test series, whether it would be subject wise, topic wise or full length test, it helped me to improve my numerical solving skills in all the domain of the subjects that are included in mechanical. It helped me to cope up with the new numerical type of problems which normally students face difficulty in solving in first go. So it helped me to cope up with this type of numericals, and also I got to know through different multiple choice questions, multiple select questions which are now in the GATE Mechanical they have introduced. So I got very good quality questions, so it helped me in preparation a lot. I am Nikhil Kumar Saha. I got AIR 1 in GATE Mechanical 2022. I was enrolled in ACE online test series program. So test series, whether it would be subject wise, topic wise or full length test, it helped me to improve my numerical solving skills in all the domain of the subjects that are included in mechanical. It helped me to cope up with the new numerical type of problems which normally students face difficulty in solving in first go. So it helped me to cope up with this type of numericals, and also I got to know through different multiple choice questions, multiple select questions which are now in the GATE Mechanical they have introduced. So I got very good quality questions, so it helped me in preparation a lot.